So we are going to start with this homework problem, and then we're going to go to another one, and then we'll go to the next whatever y'all want. So I already got the first two planned, so that's cool. Anyways, apparently the view example for this is crazy. It makes no sense to me. I don't know why they wanted to go down a crazy road. It says find the area of a surface. So we're looking for surface area. And the formula for surface area, just plain old surface area, is this guy here. Don't forget that 1. I always forget the 1, and then the whole thing blows up. That's the formula. That's the formula. And what we're looking at doing here, essentially, is we're going to find out what this little f dude is. And then we're going to do the magnitude, etc. And then just dA. So, of course, we've already seen this before. The f is basically equal to z, right? And the only place that we got a z is this guy. So 4x, y, 8z is equal to 6. How would I get z by itself? Beautiful, beautiful. So great notation. Something like that. What I want to do is I want to rewrite this in, I guess, like pretty form, because we're going to be taking derivatives of this, and if they are lined up like this, it's so much easier to take a derivative without like that fraction stuff. Cool so far? Okay, cool. Is this anything like they were doing? No. Good. In reality, that is what's going on. That's why there's that 1 right here. That's basically the derivative in terms of z, which is always going to be a 1. Which is cool concept-wise, but it has nothing to do with the answer. So, oh well. So yeah, here we go. So square root of the derivative squared. What would be my derivative in terms of x? Yeah, yeah, you got it. And then we're squaring it. And then for y? Perfect. And then you square it. Don't forget the 1. Goodness me, how many times have I'm like, da 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 da, and forget the 1. The whole thing blows up. So those little things, right? If you notice, then all of this here is just a scalar. It's just a single number, right? There's a few ways to go about doing this, but what I want to do quickly is I want to pull up Desmos Scientific and just do the inside value. So like I got a 1/4, I got a 1/64, yeah, and then plus 1, change it to a fraction, and then aren't they all squared? So I could do the square root of my answer and get a more simplified fraction. So what we have is 9/8 dy dx, and that's fine. I would almost rather put at this point dA, because it's emphasizing the fact that I'm looking for the area. I'm saying just 9/8 times the area of what we're going to be looking at. That's really the whole problem now. So now we're like going to phase 2. What's the area, right? So far, is that cool? Okay, is this better than what they did? All right, good. So yeah, let's look at how to get this area now, because I haven't even looked at it. So we got this thing. What is the shape of this stuff? Parabolas. And they're sideways parabolas. Like we got one doing this, and then because it has a 2 here, think of it kind of like the y-intercept where you're starting, and then we're going backwards. So because it's sideways, though, we're actually starting over here at 2 and coming back. So it kind of looks like that. Like we're looking for that area in there. So yeah, kind of strange. Can I easily find that area with a double integral? I think so. We have to imagine, though, it's not top and bottom anymore. What we're going to be doing is left, and right. Left, right, and then bottom and top. Essentially, we're going to have to switch it to dx dy, I believe. Yes, actually, because it's just a scalar in the front, that would work. I don't know where they're intersecting, though I think we're going to have to find that anyways. I told you have a talent for this, bro. No. I'm sorry. A little slower. Oh yeah. No, yes. Okay, yeah, sorry. Solve for it. Set them equal to one another and solve. So yeah, set them equal to one another and solve. You got it. So then 2y squared is equal to 2. Y squared is equal to 1. So my y would be perfect. Perfect. And so I want to use a different color to show and emphasize here. We got right here is a positive 1, and down here is a negative 1. And it actually just so happens to be at x equals 1 as well, which is kind of funny, but hey, it works. Okay, so yeah, let's set this whole thing up and be done with this thing. Dx, dy, what would then be on the left side? Yes. Okay, cool. And then I would put? Desmos. Of course, Desmos. It's kind of weird to do the y's up there, but in the end, there you go. That was what they had. I guess I can kind of squiggly this a little bit so it's on the side. So 3, got it. Better? Yeah. We had the basic formula. I don't know why they didn't use it. So, well, cool. Good times. Now off to the second one. So, do you remember what section it was again? 2. Sure. Question number something in the middle. Okay. Let's do it. I'm all the happy to do it. That's why we're here. 7, and I can't see anything that way, so maybe 4. Did I get it wrong? Oh, I got it wrong. How dare I? Oh, yeah, I tend to do that. So, let's do this here. So, they have a funny looking formula, but watch out. I'm so used to just when there's x's and y's, maybe like a dt or a dA. No, this is dy. It's very different, right? We're not used to just seeing a y there and no x's essentially. So this is going to be that FDR kind of stuff, but what I really want to do is kind of just make the path and plug it all in. It's almost more simple if I just do it as it looks like I'm just plugging it into all this. So we need a path, and what we need is 2 different paths. I'm going to do R1, and we're going to do something in 2D land, and we'll do R2 later. So R1, just this little path from 0 to 1 here. And again, we're talking x's and y's. So what is my x value as I travel from 0 to 1? Give me something here. What would I put there? T. That's a great one. I love it. And therefore, you are telling me now. You are telling me that we are going to go from 0 to 1 with my t. Because you said t, I need to use that as my limits. Cool right there? We're good? What would be my y value for all this? 0 all the time. It never changes. And so then we can find our r prime. So derivative of t is just 1. Derivative of 0. Good thinking. Okay. And so what we have here is a dx and a dy. And so I am going to plug it in directly. What you see is what you get. Here we go. I have x squared, and so that would be a t squared. I have y squared, so that's going to be a 0 squared. And then dy is 0. What do we get? 0, yeah. Yeah, if it's 0 there, the whole thing's 0. So, okay, well, there's one part of it. And then we're going to do the second half of it with our second path here. Okay, so I'm going from this point upward. What is my x value at all times here? 1 always. What do you want to call your y value? Yeah, if you want t, I gotta love t. Exactly. When I first started doing this one, and I probably said it before, that I wanted to make it overly complicated. So like I wanted to go from 1 to 2, but there's no reason for that. Like just it's a whole new problem essentially. We're just going to say plus sign, it'll be fine. So yeah, just keep it easy here. Derivative. Perfect. And again, we have an x, we have a y, we have a dx, we have a dy, and let's just chunk it all in. So we got 1 squared t squared 1 dt essentially. And you specified, you told me that it'd be from 0 to 1. Calculator. Like, I don't even waste time on that. Not at this point. Okay, there we go. Yay, we did it. So the whole problem is technically that thing plus that thing. So yeah, what's the final answer? It's just the 4/3. Cool. Good with that? Good with the concepts? Good. That's good. All right. Now for the game show. Yeah, Stump the Professor. Because those I was ready for, but now y'all could just toss anything at me. You like watching me get nervous. What? You don't have another one? Okay, I got more. I got plenty of problems to do. So the one that we did last time, I don't have to do that again. I'm gonna go to 16.6. Because there's a lot of good problems in there. Here we are, 16.6. And let's get rid of that. Make it look pretty again. Okay. All right. So this is like the first time that you're seeing this. I just want to specify and clarify here. When they have this d sigma, it's like supposed to freak us out for no reason at all. So when they do this, which I'll write down occasionally, all it is g times the surface area formula. Why did I put a y first? I don't know. That was kind of silly. X, y, got to remember the 1, and then dy dx, technically, dA. It's the surface area stuff, and then you're just saying multiply times g. That's all we're doing. So you went from surface area to surface integral. Whoa! That's all this whole section is. There might be a one-off that's kind of strange once in a while, but the majority of these questions are just going to be the same thing we did with surface area. You multiply by g. That's it. That's all you need to know. And so that's what I'm going to start doing here. I think that, yeah, this is the one I was going to do anyways. So let's do it. I have a g, and so I'm going to have double integral of z times, and then we got stuff, and then dy dx. That's really all it's going to come down to. We need to find out what goes in there, though. Again, every time when it says f, it really means z. We're talking z here. I should probably like change my formula at this point because that's really all it is. So then I have a z. It's right there. but it's not z equals. Sure, sure. And that is definitely a possibility, and it makes me very sad because then we're gonna have square roots. And see, I put a z in right there for my g, but then I'm gonna have to change this to x's and y's. Look, can I do that right now? Can I integrate right now? Not at all. So how about this? And I know this is the one-off, and I don't like this. This is question number one. I'm sorry, but we do have the ability to manipulate this a bit. What if I did dz dx? and hold on. No, what does Ryan 2 say again? Hear me out. Hear me out. What is it? Stay with me now. Hear me out. Stay with me. 0 to 3 for x, 0 to blah for z. They're giving me the limits. It's in a way, it's like saying, ooh, use these. Don't use y. Use x and z instead. And then I don't have to change this. I just kind of like breeze through my formula, essentially. Go ahead. I would say that f is equal to y now instead. And then just kind of roll as if it's just switch your letter in the brain. That's all. So then I'm looking back at this formula here, and I'm saying take the derivative in terms of x. What do we get? 0, okay. Take the derivative in terms of z. What do we get? Okay, we're going to square it. And then you got to remember the 1. You're done. You're done. Here, I'm going to put the limits on there so it looks pretty. But we're going to go to Desmos, and we're done with this problem, essentially. 0 to blah, doesn't really matter. 0 to 3. And then we don't need the 0. 4z squared plus 1. Now, like, all right, if we wanted to be good about this, couldn't we do a u sub? Shrug is a good answer because Desmos. It's a what? A lot? Allowed. Allowed on the final. I thought you said it's a lot. But yeah, it is allowed. That's correct. So we better use it. Z squared plus the 1 dz dx. And look how beautiful that came out. Now, I have no clue if it's right, but it does look beautiful. It is right, by the way. It is. Yeah, look, there it is. So if you go to like view example and stuff, and they give you some weird formulas, rarely are they actually needing that. I want to look just, oh, actually, it doesn't have a button for me here. The only option you have for help is to ask me. I kind of like that, but I'll check my email eventually. You're gonna send me a Blackboard message. Check your email, Chad. Yeah, I guess. I mean, I'm fine with that too. So not too bad, right? The main part is surface area as usual. Put in your formula for G, and you're done. Cool. Okay, I don't even think I did this one here, but we can if you like, or I can move on to another one that I felt was harder. Go ahead. Yes. Yes. I would, for this time, I would. And I know that you think, oh, sphere, maybe spherical formula stuff. I wouldn't go that far yet. Maybe, but not initially. Would you want to do it? Okay. One yes means a yes. So my formula will be x squared now times square root of derivative squared, blah, 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 dy dx. So that's really all it's going to come down to. I just need to find my derivatives. Well, again, I'm going to assume here in this case that f is equal to z. Move it all over square root. So easy stuff there. And I know it's plus and minus technically, but whatever. It's going to be squared here in a second. So that's my original, but now I need to find my derivatives. So yeah, let me rewrite my formula so I feel better about it. There we go. Okay, so my derivative. Derivative square root. What do I put in the front? 1/2. Leave the inside alone. What's my new power? And then the derivative of the inside is? Yes, correct. The 1/2 and the 2 cancel, and so we basically get a negative x divided by the original square root. And similarly for z sub y, it'll be the same kind of style. I think I can like squish this a little bit now. Yeah, that's fine. Cool with that? Awesome. Oh, you're fine. I don't mind waiting. So I'm going to now plug him back in. Hi, I'm so glad you're here. And you're glad to be here too. Oh, you really are? I mean, was it something like traffic or something? Oh. Okay. Well, I still like you. So, anyways, I'm going to take this whole thing and square it. And so the negative goes away anyways. And the square root goes away. So that's kind of nice. Repeat for the y. And then got to have the +1. Man, how many times did I mess it up this weekend? I was doing these problems, right? Forgot the +1. I keep emphasizing that because I messed up every time. This is, yeah, you got to be careful. Is that happy times right there so far? Okay, good. I need to get that square root better. I know that I can probably put it into Desmos right now with rectangular form, but I would have like these humongous limits over there, square root, blah, 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 you know. I don't even know if it's going to be nice or pretty or even worth typing it all in there. So what I want to do is clean it up a little bit. You know, your other professors told you to simplify every time. So now is the time to use that skill. Obviously, common denominator here is kind of easy, right? But this 1 also needs a common denominator. So I'm gonna try to do the steps kind of slow like to show you what's going on. Normally what I do on my paper is I just jump to it, but it's kind of a little misleading once in a while. So okay, there we go. I'm just gonna do dA at this point. I don't really care. Go ahead. No, because I know what you're talking about. Because when you factor that out, you still have a minus sign down here, and there's no canceling like that. You're saying something like, sorry, that was supposed to be a 3. You're saying cancel your 2's. That's not going to work. You get me? Okay, cool. But we do want to cancel here in a second. There is some canceling, but just not that. Notice that all of this was my 1, but now I have that common denominator. And so what I'm going to do is essentially extend this line here and do that. So what happens now? If they're all in the same numerator now. Cool. Yes, yes. Beautiful, beautiful. So much easier. And so let's rewrite this a little bit. We got x squared. I got my 16 over a single common denominator now. I don't like that. I just want dA at this point. And I hope that you're starting to feel something coming, because trying to keep it in rectangular is not going to be happy. I'm feeling polar mode coming on, but we're still not there yet. I think that we can go a little bit further. Maybe. Yeah? Are y'all okay so far with what we did? Okay, cancel, exactly. So square root of 16 is going to be a 4, but then I can't do anything about that. And this guy here is not directly canceling anything else. So the simplification is almost done. I can't really do much else. I think that it is best to probably move to polar mode pretty much right now. So here's where it gets interesting, of course. X is technically r cosine theta, and I'm going to square the whole thing. Oh, wait. Remember that 16 up at the top technically turns into a 4. And then I have the square root down here of 16 minus, what would I put here now? Very good. Required r dr d theta. Again, I've been doing dA on purpose because it needs to convert into that. Of course, we're going to make this look pretty. I got r cubed cosine squared. I got that 4 in the front. And then I'm supposed to divide all this by the square root of 16 minus r squared, I guess. Dr d theta. Desmos, for sure at this point. Oh. Thanks, Desmos, for doing that. Right? I'm like, go to Desmos, and then, wait, I can't. Let's go back and look at what's going on. So we have this sphere. So then we're talking about like a radius at this point, right? What would my radius go to? Just take a guess. Yeah, exactly. That's what I'm thinking too. My theta, 0, 2. Yeah, 2 pi. You got it. Yeah, you got it. Let's try it out. I mean, these are just basic things. If it doesn't work, it doesn't work. We try something else. But I'm pretty sure that this is where we should be going. Oh, not down there. Of course. Okay, now actually that's not too bad. So I got 170.666666666667 pi, right? But then I can convert this. It just, Desmos kind of let me down a little bit, but all right, there we go. So I don't know if this is right or not. I don't think I tried this one, but it seems like it's cool. I'm willing to give it a shot. Chirp. Okay. So 512 pi divided by 3, and no! No, I don't trust that. It's fine. Yeah, it's fine. Maybe see, and it could be even something right here from the 0 to 4 stuff. But let's just see. I want to see what they. Okay, look at what they got. I got it. I know what's wrong. Oh, it's so annoying, these tiny concepts. It's okay to get things wrong so you can see what's going on, right? We are not far off. Why did they double it? So, oh, you got it? So, I'm looking at you guys. I'm about to go to YouTube and see how many views I have on my lecture videos. Because I did this one. So I actually addressed this in the lecture video because it is one of these weird concepts. Like the sphere. The sphere. Let's draw a sphere, guys. Right? What we were doing was the top half only. Exactly. Exactly right. We're basically just saying from 0 upward. I don't know if I would go that far. Maybe. I mean, I feel like it might cancel it. See, now that's a 0. So it's more of a concept than anything. That I was really only working from 0 to whatever. The reason why I'm doing 0 to whatever is because of that shadow. So let's just take the sphere, well, okay, like the dome, the top half of it. If I look at it, it was a circle, and this is circle, isn't it? It's a circle. So I'm looking at the shadow of what I'm looking at, which is basically just the top half, the dome. Like I'm specifying here as a double integral, not a triple integral, that z has got to basically equal 0. I'm saying that. That's the problem. Okay. Did you get the point though? Now watch on the next one or the one after it. It's just it gets hilarious. It right here. Look. How mean. Look. Right. So this one you won't double it, but the other one you do. Anyways. But I can do this one if you like. It's the exact same problem, except that we got hemisphere. Look, they're even saying make sure it's 0. You want me to do it or not? That would be a no. I mean, it's not up to me. So I can move on and we can come back and do this one tomorrow if you want. Okay. Because I have that one technically written down over here. I haven't done this one. I guess I just skipped it, but I mean, I could do it if you like. It seems kind of easy. You can see how they lay it out for you. Okay, good. This guy looks a little bit more difficult on the formula, but it's just a dome. Again, look, only above. You have to say yes or no. Yes, one yes means a yes. One yes is a yes. I love it. Okay, cool. So it's Stump the Professor Day because I never did this one, but I did look at it and say, I think that's okay. I still hold the right and reserve to delete any problems I don't like. So this is my big formula, and then I'm going to do the square root of, and this is where we have to start making decisions. I believe that I do want z as my f, so z sub x squared, z sub y squared, got to have the 1, dy dx. But if I'm doing dy dx, do you see a problem? Right? What I'm going to have to do then is I'm going to have to change this to be that. I'm going to switch sides. I feel like I want to switch sides if that's okay. All right, here we go. You're ready for a big mess. I know it. Big mess. So I replace my z with what they said was z. And then I need to start taking derivatives of this. In terms of x, what would I get here? Yes, very good. Square it for my y. Perfect. And then got to have the plus 1. There we go. I practically am done. Like all I need to do is toss in some limits and I'm fine. I just don't know if that'll be easier or better. Like look around for a second. Would you rather go to polar mode with this? Sometimes you're saying yeah because they line up here, not kind of nice. And the inside there's not too bad, but here then we got a hanger duder kind of messer upper. I don't know. Mm-mm. Mm-mm. I'm gonna try to do rectangular just because I think it's funny. Yeah, I know. I just want to just this is my answer. This is Desmos, okay? Desmos right now, but I need to put some limits on it, right? So what we're gonna do to find the limits is we are gonna set the z equal to 0. You can see they're trying to tell you that a little bit. So I basically set that equal to 0, and I want to solve for y. And so I'm going to move the y over and divide by that 3 here in a second. Oh, you know what? That's actually kind of nice. Look what happened. It's not too bad. So then, plus or minus the square root for my limits. This is why I normally go to polar mode, because I have to kind of write at 45 degrees to fit it all in there. That's fine. As far as my x's, what if I got rid of my y? Yeah, plus or minus 1. Exactly. Let's try that big thing and hope for the best. So, as I type for the next hour, y'all doing okay today? I shouldn't be asking that in your finals week. Bad Chad. Oh, see, I'm about to mess it up there. I know that y'all will be fine. No doubts in my mind, y'all are going to be great. I think what is going to be the most, the determining factor for y'all of things is, which passing letter grade you're going to get. So, there's nothing else. Yeah, what I was doing, though, was I was basically getting rid of that and setting it equal to 0. And then we got this, so plus or minus 1 there. Oh gosh, I just wanted to finish this up. Okay. That's ugly. Oh, throw a pie in there. Oh, look at that. I know. Well, here's the thing. I was tempted to do polar mode, right? I kind of felt like it might have worked, and it will. But because it would have worked in polar mode, I gotta expect pies. It's just gonna happen. I know, but that is kind of funny though. What's not funny is that I'm not able to type it in there. Cool. Not too bad in the end. So you can see surface area formula. Throw in a formula that they have for the G and you're done, right? For most of them. I can keep going. I got others. You want me to keep cruising? Okay. So this is one I did. I think I just did it because I was debating about the last word of this one. It's actually pretty straightforward. Notice it says first octant. So we're going to go from 0 to a number, 0 to a number, rectangular form. You like fighting a sneeze? Okay. So I'm not worried about that one. Let's see what else we got here. That one looks scary. I mean, look, it's even got this FN stuff. Ew. Want to do it? Cool. And I already did it myself. So there you go. So it says in the outward direction, normal way for x-axis across the cut surface of blah, 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 blah. What? Now, here's some things that we're going to have to note about this one. Let me get a little bit more room here. So they're looking for a double integral of f dot n d sigma. When you see d sigma, what they're trying to tell you is blah, 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 and then we're going to do the fx, the fy, the 1, dy dx. That's what they're trying to say with that. So it's the same as what we just had. Keep that in mind. It's the same thing. So what is this stuff in the front? It's just my G, essentially. That is the worst G I've ever done. Let's try that again. It's essentially a G. Still doesn't look good, Chad. Anyways, so we're wanting our G formula to be this f dot n business. Well, we have an F. Look at that. That's not too bad. We have an F. So what is N? And that's what it has, this outward direction, blah, 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 blah stuff. Okay, so let's talk about this one. It's actually pretty easy in the end. We just have to know the concepts. So X, Y, and Z. I'm going to draw this parabolic cylinder thing in a different color. It's only for Z and Y, therefore X doesn't matter, and it's basically a downward parabola that it's like a tunnel. It's like a tunnel. Look, I'm making a spine right now. Ooh. There you go. So we have a tunnel, and you're driving through the tunnel. Easy enough. They're saying that we're going from x equals 0 to x equals 1, and then z equals 0 is the bottom plane here anyways. So we're just cutting it off right there. There's our tunnel. We have a tunnel. Cool with the tunnel. You're okay with the tunnel? Okay. So yeah, what it would look like on this is the xy plane, and this is z. It looks like just a parabola. And I'm just going to drive through it. Actually, I can't say xy plane. That should be just x, or no, I think that's y. That's y. But regardless, we're just driving through it. Cool? Parabola. I have the f. Check. I have all this business. Check. So what would be my n? And this is where it's easier to just kind of throw something out there. We want the normal vector that's going to work for all the stuff, concept-wise, yada, yada, yada. Gradient of this and blah of that. Oh, I don't know. Let's just do this and it'll be fine. So I think it will be fine. I think it will be fine. So I'm purposely choosing something simple because there's a lot of concept behind it. But stay with me. Stay with me, and let's see if it'll work. Is that okay? And then we can come back and talk about why I can simplify it sometimes. Okay, you're gonna stay with me. I know it because I like you guys. So here we go. I'm gonna redo my formula. I got z. Oh no. This is a vector z squared. I put a plus sign. Silly Chad. Negative 3z. And what if I said dot 0, 0, 1? What if I did that? And then times the square root of blah, 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 blah. We'll figure that out in a minute. And that's the point. Man, that makes it a lot easier, doesn't it? Everything else goes away. It's just these guys. If this works, then I'm happy. Because I want to simplify it. I want to keep it easy. This is the way to do it. What then would I do for my derivatives in here? Essentially, if this is supposed to be z sub x squared and z sub y squared, and the only z I got is this guy. So then, what would I do for my derivative in terms of x? Yeah. And in terms of y? And then plus 1. Gosh, man, look, I even forgot it up here. Do you see it? You go and get it wrong, and you're like, why am I wrong? It's plus 1. Anyways, we are so super close. There's only one hiccup left in this integral here. Exactly. We can't keep that z. The z is equal to 16 minus y squared. Doing a little bit of simplification. And now we're happy. The last thing I need is some limits. Again, we're looking at 2 dimensions, though. So they told us 0 for x, 1 for x. And we have this parabola that's going to hit at z equals 0. Oh, I don't know. What if I just set those equal to one another? So there you go. I know I'm kind of bleeding into the top of the problem. Sorry about that. That was my issue. So yeah, we basically have positive 4 and negative 4. Oh my goodness. I just made a rectangle. How nice. So for my y, I got negative 4 to positive 4. For my x is 0 to 1. Desmos, done. So I'm saying I got z equals 0, and I got z equals this stuff. So you just combine them, and then 4. So I'm going to go to Desmos with that guy. Expand a little bit. There we go. Cool. All right. Did I not do something? Bless you. That doesn't look pretty at all. Sure. No. That's not very happy, is it? Is anybody happy here? Yeah, go ahead. Um, Probably because it's symmetric with my y because of the square. So negatives or positives for y should be fine, but that's not going to hinder you. That would be if I had to do it by hand, it would help. But here I'm trying to use Desmos. Again, I would be very careful with that. That's fine here, I'd say, but not everywhere. Oh, you did watch it. Oh, so you're saying right here, this part's not happy? Oh, that's sad. Let me look at my notes real quick. I think you're right, but let me see what we got going on. Oh, look, and I have the answer. So I'm like way off. Okay, so what did we have again? Oh, with the pi. Okay, so yeah, let me get. Oh, it's pretty close. That's pretty close though. It's pretty close. Real quick, let me because I think I did this one, or at least I had wanted to do this one. Oh, I did. Yes, I did. I did do this one. So on this one, I think I did some ones before it. No, I didn't. I just went right in, and I had to do the other formula. Okay. Okay. Well then, here's the thing, and this is a perfect time to know that yeah, we tried something. I even did a shortcut, and it blew up. Yeah, and that's fine. What do? We start over. Yeah, we start over. I know that sounds sad, but this is an okay thing to do. I thought I was being really funny, like we can do this, but no, I just messed up. So I'll admit when I'm wrong. Let's go to the workbook. And I want to look if there's a formula for this one specifically. Again, we're looking for the F dot N D sigma. Is there a specific formula for that one that can help me? Okay, I'll just full screen it, I guess. And more specifically in 16.6. That's where we are, right? 16.6. Okay, so this is what I was doing, and that looked really cool. See, this was what I wasn't doing because I was doing this formula every time. That was nice, but and this one's like scaring me and stuff. But then, aha, that's what I'm looking for. And then flux is this guy. Notice that it says flux here. This is the flux formula, and then I put flux right there. So, do I have an F? Can I make something here? Maybe. That's a maybe. So let's kind of explore that one for a couple minutes, okay? So I'm going to rewrite that formula. We got double integral of f dot ru cross rv d what? du dv. Yes, you're right. Okay, that's good enough. Okay. Back with the homework problem. There we go. So I have to pick a u and a v. I have to pick something. And a lot of times what we do is like an r and a theta, and I'm going to use that in other problems. But here, I don't think polar mode is going to be the way to go. So I'm going to be a cheater, and I'm going to do u is equal to x and v is equal to y. Is that what I did? Really? You watched it? Did you like and subscribe? Anyways, so I'm not cheating here, but I'm trying to keep it as easy as possible. So if that's the case, I'm going to go through this RU. Wouldn't it be the same thing in the end? Bro, don't tell me. Look, guys, look, watch this, watch this. Okay, just hold on for a second. This will be actually kind of hilarious. Okay, so my first vector is this guy, and I'm saying cross this guy. Oh, but I have to do the derivatives. I'm sorry. This and this. There you go. Notice that we're having to do r sub u, so we're basically saying r sub x. It's like, what's my derivative here? What's my derivative? 1. What's my derivative of this guy? Just take a guess. Just anyways, so when I'm crossing these, I'm doing this. And so when you, gosh, wrong one. Sorry. It's this one here. So when I'm crossing this, I should get this guy. What's x cross y is z, essentially. So that's, and didn't we see that last time? Didn't I say, I mentioned it? I was like, oh, look. Well, now I'm telling you the concept of why. It's because if you pick some easy ones here, then you can just easily get an answer. Okay, so don't overcomplicate it, essentially. Okay, when you're having to use this kind of formula, this is the way to go. And that is my n. That is my n, essentially. So I was really close to the right direction. I was so close. Let me go back and put my f in. So I got x squared, I'm sorry, z squared x negative 3z. I'm going to say dot 0, 0, 1. You're going to laugh at me here in just a second. du dv. But wait, du dv. Hold on, I'm going to get back to this. What was my z equal to again? Sweet. What was my u equal to? X. And v? And you could switch them. I don't have the thing I had up previously, but you were taking notes. What's the only difference between this and the last one? There's no square root. There's no square root. So without being too funny here, what if I went back and just deleted this square root? Everything else being the same. Isn't that magical? So I went too far. I went too far. I didn't look at the right formula. It said flux. I go to the flux formula, and I went too far. I just went too far. Look how easy that was. And I feel dumb, and that's okay to feel that way once in a while, because then you're like, I could have done this, and you can get better. It's okay. We only got 3 minutes. I don't know if we got enough time for another one, unless you want me to try. He doesn't want it. Yeah. Is this okay though? What I did? I was so close, wasn't I? I was so close. I just went too far, and that's okay. It happens sometimes. Let me just real quick look around at the homework, like what we got left. So we got this guy here, very similar. I actually have this one down, so I did it. I didn't do this, but I think we did this one on the workbook. I think that's a workbook one. This one was super easy, I think, so I just didn't want to do it. Like you can see it's rectangular, and you can even see it just says K directions. It's like super easy. And then this guy, I did this one on my notes. So we'll do some more of this next time if that's cool with y'all. Because we're going to run out of time, obviously, by Thursday. Today's Wednesday, isn't it? So we're going to run out of time. We can keep doing this and reviewing as we go, or we could just review for the final exam next week. I don't know. But I would like to show up next week. Monday, Tuesday, Wednesday. Thank you, guys. We'll figure it out.